This video goes over Chapter 8, the facility location problems. There's a volume cost problem in problem 3. There's a multi-factor analysis in problem 9. 13 is a center of gravity. So for problem 3, the given data is they tell you that we've got two locations and we need to decide which location is best and when is location A or B best. It's going to be a function of demand, of volume. So when demand is low, we may have a different decision than when demand is high. They give us the fixed cost, and you can see that location B is more expensive to get into initially. The variable cost is a little bit less, and we sell the product for $17,000. So in class, when we covered this, we just focused on costs. But since they gave us the sales price, we can actually focus on profit. So the formula for determining profit is the sales price times the demand minus the variable cost times demand just minus the fixed cost. Or how I wrote it, I took the difference between the sales price and the variable cost to give me a unit profit. So for product made at facility A, the unit profit is $3,000 and the unit profit for B is $4,000. So I take the difference between the sales price and the variable cost multiplied times volume or demand and then minus the upfront fixed cost. And notice I put dollar signs around my row references 1, 2, and 3, and then my demand I put a dollar sign in front of column A. And then that way I can copy this way and I can copy it this way. How I chose demand on increments of 10, that was just trial and error. I could have changed these, I could have done it, I could set these all up, but for me, for this particular problem, increments of 10 turned out to be the best. But you can easily change that. So, once we have that, I built a scatter plot where I grabbed all of this data and built a scatter plot like that. So now we can tell a story. So the x-axis is my volume, my demand, and my profit is plotted on this axis. So the higher the better. This is profit. So you can see that blue dominates up until about right there, and then orange dominates. So you can see that blue is better up until about point 120, where demand's 120, and you can just see that's when they're equal. And then after that, location B dominates. Higher the better. However, neither one of these is profitable until we get to at least a volume of 230. So I'm not going to choose either location if I can't get a volume of at least 230. After 230, the only one that would be worth doing would be location B, because it's always better than location A once the demand hits 230. Okay, so that's how I would answer that one. Problem 9 is the multi-factor rating. We're given these factors, these 6 factors. These are the weights for them. This is all input. And then we got standardized scores for each of these locations, A, B, and C. So the question is, which location is best, A, B, or C? And we're going to do that by calculating a weighted average or a weighted value. And we're going to do that by taking this times this plus this times this plus this times this. And that's what the sum product is. The sum product formula calculates the product of each of these pairs and adds them up. So in this case, A wins. A has the highest score. It's better than these two. The higher the better. So in this case, location A is better. Problem 13, we're given this data, and we need to determine a new location. When you do a center of gravity analysis, you're given customer data. These are the customers you're trying to serve. This is the volume we're trying to ship to each of them. These are the coordinates of our customer, and we're determining a new location that would be best to serve these 4 locations. That's what a center of gravity does. So how do we do that? is that we take these x-coordinates multiplied by these quantities, and then we divide by the total quantity, which is, in this case, 90. So that's a formula. It's a sum product of these and these. That's my numerator, and then divide by the total sum, which is 90. I could have just referenced 90 if I wanted to. That same formula, but now it's the y-coordinates, and that's how these are generated, 6 and 7. They can be real numbers. I don't think in this case they are, but they could. They could certainly be real numbers. Once you have that data, you can grab this, go and insert, scatter, but let's use the bubble plot. You can use either one, I don't care. And then you can click on one, left click on one of them a couple times. That's the center of gravity. It's the biggest. The reason I know it's biggest because it has the largest quantity. That's the largest quantity. So, and then I changed the color of it. And that's how I wound up with this. So the center of gravity is 6, 7. This is a picture of it. If we had to ship more stuff to this coordinate, which is 9, 4, so right now the volume that goes there is 30. But what if that had to be like 300? You could see the center of gravity would move closer to it, and you would want to build a new location much closer to this customer because there's a lot more that goes there. Okay, that's the solutions for homework out of Chapter 8. Thanks.